Okay, quick announcement. Quick announcement. Apparently, they changed our classroom to Very Hall 3006. Okay, but we'll switch to 3006. Seems to be a better classroom. Okay, we'll just go there from Wednesday. Okay, good. And we're gonna. I said that I would talk about the example of compiler number 2 a little bit in more details. I decided to delay that a little bit. Once we talk about intermediate representation, let's delay that a little bit. Okay. Well, what I would like to start today will be to review what we should know about theoretical foundation for scanner. So we're gonna do regular expressions. We're gonna do DFA, NFA, epsilon NFA, and also conversion. Okay. I will try to spend no more than 2.5 classes on this because you guys learned it before, also 2 years ago. I try to just give you more review, but the slides should be quite self-contained. You can also study them. Okay? And as another incentive to push you, quiz number 1 is next Monday. Okay? Okay. So I would say for quiz number 1, as long as you know how to do the examples and the slides, you should be okay. Of course, you can also read the textbook. You'll definitely cover this lecture. For Wednesday, yeah, I think I'll confirm with you. But let's see how much we can cover today. Okay, maybe you will cover Wednesday as well. But between Wednesday and next Monday, you still got time to study, right? All right, let's see how much we can do. Okay. Basically, the way I do the review, I try to give you some formal definition, and then we'll do examples. Okay. If there's anything that's bothering you, interrupt me. And if I'm going too slow, you can also ask me to speed up as well. Okay. Good. Let's see. All right, let's see this. We talked about this diagram already. Okay, we talk about scanner. Okay, that's the part you can read. Okay, we already talked about it. Basically, we're going to talk about the way to specify regular language. Okay, this is the diagram that you have to keep in mind. Okay, this is the order I'm going to go for this particular lecture. Okay, I will start with regular expression. And then I will talk about DFA. Okay, I'll talk about and then DFA, and then I will talk about NFA, and also epsilon NFA. Okay, these might sound familiar to you, but I know it's been 2 years. We'll try to do some review. After this, we're gonna do 2 conversions. Okay, how to go from regular expression to start with this. How to go from epsilon NFA to DFA. And then how to go from regular expression to this. So eventually, you will be able to go from regular expression into DFA. And then later, we hopefully will also talk about how you can minimize the number of states in your DFA. Okay? And then one more thing to cover would be, given a DFA, how you can implement a scanner accordingly. That's eventually what we have to cover. Okay? Of course, many things have been covered in 2001. Again, we should review. And then I'll make it precise exactly what you should study for quiz number 1. Okay, I'll announce that either tonight or tomorrow morning. Okay, so you can study ahead. Okay, let's start from the very basics. Let me just go over some definitions, and then we'll go back. Okay. Okay, we'll talk about alphabets. Basically, it's like a character that can be included in your tokens. Okay, should be finite and non-empty. Okay, usually we just say sigma. Okay. And example, it can be the sigma for English. Okay, it can be also the sigma for binary. Okay, that's maybe something you use a lot in 2001. For this course, I think for the alphabet will be basically whatever character that will be useful for your language that you want to define. Okay, alphabets. And also it can be decimal integer from 0 to 9. Oh, one thing I want to mention very quickly just to make sure we understand the notation. You learned about something called set comprehension notation previously, right, in 1090. Let me just review very quickly the syntax. Set comprehension. Basically, curly brackets, and then we have 2 parts separated by the vertical bar. There will be some term over here, and then there will be some Boolean condition over here, right? The condition can be as complicated as necessary. For example, you might just say 2x, such that maybe 1 less than or equal to x less than or equal to 10. Okay, this overall is going to be a set of cardinality 10. Agree? And then it's going to be every x X over here is bounded by 1 and 10. So that can be 2, and then 4, and then 6, all the way to 20. Okay? Are we okay with the set comprehension? We will see that quite a lot in the slides. Okay? It's a very standard notation. Okay? When we define the language for DFA, NFA stuff, we need a set comprehension to help us. Okay. Okay. So now, also the sigma for the keystroke. Okay, so we're going to use either enumeration or set comprehension, as I just said. Strings. String will just be a finite sequence of characters, basically. So you can think about your Java program is like a single string. Whether that should be in the language for Java syntax, you have to implement some compiler to decide. Okay, and for example, this word is an English word. That's definitely there. Okay, and then 01, 010 is a string for the binary. Okay, and etc. Okay. On the other hand, you can see this one over here is not. Very quick check. Why not? The period, exactly. It's not part of the alphabets, right? Any character that's not from the alphabet will make it an invalid string, invalid token as well. Okay, that's good. 57. Okay. So now, very quick question here. Is it proper to say the following? I heard no. We are basically asking whether the string 01010 is a member of the alphabets of binary number. Okay? It's not a member, right? What was the set for sigma 01, right? So of course it's not a member. Notice the following. Okay, I'll just say we're going to see that. Basically, you have to know the difference between when I say 01010. Is a member of sigma binary versus 01010 is a member of sigma binary star, cleaning star. So this will be okay. This is not okay. Okay, we'll get to the definition for this in just a moment. This one basically just talk about strings of all possible length. Of all possible length. Yes. The string, actually the string can be empty. That's okay. The alphabet itself is not empty. For example, let's say this. Okay, I'll just talk about it quickly. For example, if we say sigma binary is simply equal to 01. Let's do this easy one. If I say sigma binary, if I just put 1 over here, what does that mean? That simply means I want to get all the strings drawn from this particular alphabet of size 1. Okay, how many strings do I have? Just 2, 0, 1, right? That's easy. And then let's just do one more. If I say sigma binary 2, how many do we have? 4, 2 to the power of 2, right? 0, 0, 0, 1, etc. 0, 0, 0, 1, 1, 0, 1, 1. One more. If I say sigma binary of 0, just empty string, epsilon. Because that's the only string that's empty. Yeah. If you say 1, 0, yeah, that'll be fine, because for the set, the order doesn't matter. However, notice one thing, right? If I ask you about this versus this, even though they look just the same, but they don't quite mean the same thing, right? If you think about this set over here, we just talk about 2 alphabets. Either can be alphabet 0, it can be 1, either character. But the 0 here is a string of size 1, just containing that character, right? This is another string of size 1, okay? Not quite the same.
For the epsilon being without the 1, can you include the empty?
Epsilon is just a string. You can think about, we're thinking this way. Epsilon, first of all, you can see this is a set of cardinality 1. It's only a single string. We can think about epsilon is something like quote, nothing there. It's a string, just nothing there.
But we can include in the language.
We
So technically
No, actually, okay, which part are you confused? Which part? Sorry.
When we compare the binary and binary of size 1,
Mm-hmm.
binary can also include the epsilon.
Oh, no, no, no. This guy here, this is only talking about alphabets. Right? We're saying that for this particular alphabet, how many possible characters can you choose from? It's either 0 or 1. Right? Okay. And then one more thing. So if you talk about sigma binary and then star over here, it would be sigma binary string of size length 0, length 0, union sigma binary and the length 1, and union altogether. Basically, just talk about the language should be the order string of all the possible length, basically. Okay, guys, are we okay? Yeah.
So, what if instead of 0, 1, you had like 0, 0,
Yeah.
and then 1? What would, like, if you want to say sigma binary 1, would 0, 0 count as like 1 or like?
So, well, basically, if you have 0, 0 over here, apparently the length is 2. So you would say this is not a member of sigma binary of length 1. It's definitely not. Right? Because when you talk about the string here, you just counting how many characters you have in the sequence. If you got 2, that means the length is 2. So it doesn't belong to this particular set.
He is asking if that was an alphabet.
If that was an alphabet.
0, 0 was a member of the alphabet instead of 1, 0.
0, okay. You mean if you say 0, 0 is a member of sigma bin? Is that what you're asking? Okay, apparently this is also not right, right? Because this one is simply just 0 and 1. Is 0, 0 one of them? No.
I know, but like say it's not sigma bin, like another binary calculus
Mm-hmm.
The first one is 0, 0.
Yeah.
The second one is
Oh yeah, sure, sure. Yeah. You're basically asking this. If you got sigma another thing, right? I would say my alphabets. 0, 0, and then 1, 1. Let's say, okay? Now, if I say 0, 0, 1, 1 is a member of sigma mine, would that be true? No, right? Because 0, 0, 1, 1 is not there. It's not true. If you say 0, 0, and then sigma mine, so that'll be okay, right? Also 1, 1 as well. Yes?
0, 0, 1, 1, the top one would be sigma mi 2, 1.
No. So this is only, this thing here is the alphabet.
Yes, sir.
So that means you can choose any string from here to really compose. You can choose any character, you can choose any member in the alphabet to compose your string for the language. Okay, good.
So sigma mi squared. 0, 0, 1.
Oh, good. Okay,
Sigma mi
good.
squared.
I see what you mean. What about sigma mine and then square? Okay.
0, 0, 1, 1, 1, 1.
Something like that. Basically, when I say length 1, it's about composing individual characters together. So now in this case, you would consider this as a single one. This is just another single one. So now in this case, it would be, for example, here, 0, 0, 1, 1. Okay, and then also 1, 1, 0, oh, actually, okay. Let me just be precise. 0, 0, 0, 0, 0, 0, 1, 1, 1, 1, 0, 0, and then 1, 1, 1, 1. Okay, good. No problem. All right, good. Okay, so that's about the alphabets. Okay, talk about the length. That one is easy. The same notation, right? Just vertical bar, right? Just to know the length. Okay, that one's easy. Okay, just notice that the epsilon for the empty string. Okay, and we talk about concatenation, right? Just put the string together. Okay, that was easy. I don't need to trouble you with that. Okay, about the string. That's something we just talked about. Basically, once you put an exponent, it tells you how many characters you should choose to make the string. Okay, so now you can think about our set comprehension. Think about sigma k is all the string such that it's actually from that, and then the cardinality is simply just k. Okay, that was easy. Okay, if there's any definition not clear, please stop me. Okay, that one there we already talked about. Okay, and then sigma 0 is epsilon. Okay, we already talked about it. And sigma plus, basically just all the non-empty strings. Can be size 1, size 2, size 3, just except for the empty string. Sigma plus, okay, that's easy. And also sigma star, that's also, okay, basically sigma plus union the epsilon string. Okay, I guess so far quite straightforward. Okay, just remember alphabets and also how you can compose strings from the alphabets. Okay, so these are some exercises for you, okay, just to review. Just about this one here. What would be the size for, let's say, from A to Z? So the alphabet size now is 26 characters in English. And I'm not asking you to enumerate them, okay? I'm not going to ask you that either in the quiz or exam, don't worry. But what about the cardinality for this particular set?
All words, but it could be jarble words as well, of size 5. With 5
26 to the 5.
Huh?
26 to 5.
26 to the 5. Okay, do you see why?
You're saying, yes, sir.
Very quickly, just for those of you, I'll just do the first one quickly, okay? So now if I got A all the way to Z, this itself is an alphabet of size 26. And then I'm saying that it should be to the of all the string of length 5. So 1, 2, 3, 4, 5. How many possibilities? 26. And this one I can choose any 26, right? All the way to 26. So that'll be 26 to the power of 5. Okay? Just very basic operation just to understand. Okay? Okay. Yes. Oh, actually, no, there's no for empty string. Oh no, it's only 5, right? So that means you want to only get length 5. So there's no empty. Yeah. If I say, for example, A all the way to Z, 0, that will be empty string for sure, right? Okay, good. Okay, for other review exercises, take a look and see how you can. This one's easy. Okay, just enumerate them. Okay. Explain the difference over here. We actually did it just a few minutes ago. Okay. Okay, so these are some simple exercises for you. And when I say prove or disprove, you don't have to do the formal proof, just to have some informal arguments to convince yourself. Okay, that will give you some insights. Okay, languages. So we talk about alphabets, we talk about strings, and now we talk about language. Basically, language will just be a set of strings. So now, think about a language over here. Okay, I'll give you one example over here. So now, let's say this. Let's say this. If I got this particular alphabets, let's say A to Z. Okay, all the 26 English alphabets, characters. And then if I say star, okay, apparently this one here tells me all the possible combination of characters of different length, starting from length 0 until length finitely infinite. Okay, so now can I say this is equivalent to all the English words? Okay, if you believe no, you want to give me one counter example. Okay, very good. Yeah, exactly. Apparently, you can see this guy here. AA is a member of this particular thing. However, AA does not exist in English, right? Basically, think about these. This is a big set, A to Z. Only a subset, strict proper subset of that is English. Okay, are we okay with this? Okay, so basically that's what I said in the slides. And over here you say any language will just be a subset of all the possible strings from that particular alphabets. You just choose some. Okay. Okay, so now, okay, language. And for example, what about a language for Java, right? Basically, think about if we want to use the set comprehension, okay? Any valid Java program will be such that whatever you can type from the keyboard, and that can be compiled, basically, right? So the way I write this would be, I would say, first of all, you can see it's a program that is a member of sigma key star, which means whatever I can type, right? But is whatever I can type is a valid Java program necessarily? Not quite, right? I can type just some random junk. Yes?
What if you have a different language keyboard?
Well, the syntax of Java is still
Yeah, still in English, right? Yeah, yeah, that's a good question. But I'm just okay. How about this? Let's say you got an English keyboard, right? You gotta switch to English mode. Let's not be so complicated. Yeah. Okay. Yeah. When I say keystroke, not just alphabet for the English, but also any parentheses, at, whatever. Anybody went to Very Hall 306? Oh, okay. Good. Yeah. Yeah. Anyway, we'll switch to Very Hall next time. Okay, I'll just say program compiles in Eclipse, right? So this one here, basically just to tell you how you can use a set comprehension to specify the language, okay? Of course, this part here, the program compiles in Eclipse is quite vague, right? Okay, but that's okay, just for the illustration. And also you can see this guy here, it's actually 0 to the n, 1 to the n. Okay, that one's easy from 2001. Okay, it's just another one. Okay, just with the equal number of zeros and ones. Okay. And by the way, if you want to specify a DFA, for example, for equal number of zeros and ones, it's not actually regular. Okay, but we don't have to prove it for this course. Okay, it's back in 2001. Okay, languages, and then there will be some exercises for you. Okay, you can just take a look and see how you can do them. Okay, 5 review exercise. If you want to discuss your answer with me, please drop by my office hour. Yes. Oh. Sorry, which one? Which bullet point? 3? Oh, I'm just saying it's sigma 1 and sigma 2. Yeah, just that. I just want to distinguish between the two sigma. Okay, good. But for the quiz, I'll be reasonable since you only got 15 minutes, right? It'll be something that should be quite easy to do, straightforward. Okay, no trick for the quiz. Okay, we talk about alphabet, we talk about string, we talk about language. Finally, we talk about problems. Okay, as far as the context is concerned. Basically, given any language L, which is a subset of the alphabet star, right? We talked about in the previous slides. Given any input string, we want to decide whether W is a member of that. So now I'll put that into the context for this course. Any user, they give you a program, individual words separated by white space. For example, thinking this way, okay? So now let's say over here, if this is an input program that you're given, let's say class followed by some white space and then A, and then etc. This will be considered as a token. You can think about this as like a W. And then you want to see if W somehow is a member of some L. And the L here is actually a regular language. And how do we specify that regular language? In the parser generator, you're going to use regular expression, which we'll review how you can do it. But in order to implement it, you have to somehow convert the regular expression eventually to some DFA. Okay, that's something we're going to see. Okay, just put things into context. Okay, question here. Is this equivalent to deciding this? No?
Yeah.
I heard yes, I heard no. Yeah, exactly. I'm just saying, are they, well maybe, or let me put it this way. Yeah, sure, how you check it is definitely can be a little bit different. So let's say W is a member of L, and W is a member of sigmas. Yeah, I know. Yeah, I'm aware of that. Yes. Okay. this is what I'm asking. This is a Boolean. This is a Boolean. Can I say this implies? This is true because, yes, because L is a subset of sigma star, right? Can I say this? No, because remember the diagram over there, you got L over here, you got sigma star here. You might be just giving something over here, right? Okay, good. Not necessarily. Okay, that's basically exercise. No, okay, but the reason is I just explained that. Okay, let's talk about regular expression. Okay. For regular expression, okay, it's a language defining notation, easy, okay, similar. Okay, eventually we're going to show that how we can convert our regular expression into epsilon NFA, and then to NFA and DFA, etc. Okay, that's what we're going to see eventually. Textual. So this is the notation you have to write when you use antler. Okay, I'll show you example later. But for now, let's focus on the theory. Okay, so now let's just get the notation right. Okay. Just very quick review. So we got 0, 1 star. Okay, star means 0 or more occurrences, and plus means either one, right? Like alternative. In the textbook notation, I believe you will see something like maybe the regular expression E and F, they simply prove vertical bar. That will be fine too. Okay, you can either say plus, that would be in my slides. If you say vertical bar following the textbook, that's also fine. Okay, either one works. Okay, so now 0, 1 star and 1, 0 star. Okay, there's something about operator precedence. Okay, I'll mention that very quickly. I'll switch that in just a moment. Very quick. Do you think the length? Oh, you said no already. Good. Yeah, good. Yeah. Do you think this is incorrect? Yeah. Oh, okay. Are they unequal? So you said no. That's wrong. Anyway, okay. Yeah. That's fine. That's fine. You know, teasing you. Okay. 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 Apparently, these two regular expressions represent different languages. Okay. The reason is something about operator precedence. Okay. So now here you're basically saying, I'm taking the 1 star first, because the cleaning star has higher precedence. Whatever 1 star is, concatenate with 0. And this one here, the parenthesis force 0, 1, and then take the star. Okay, so these two are not the same. Okay, and if I give you this question in the quiz, of course you will say no, they are not the same. But now I want you to give counterexample. Okay, so now let's say this is A, this is B. Can you give me something that's in A but not in B?
0, 1, 1, 0. 0, 1, 1.
Well, 0, 1, 1, that's easy, right? Yeah, it is basically alternating, right? 0, 1, 1 is in here but not here. Or just 0. That's true. Absolutely. What's in B but not in A? 0, 1, 0, 1. Okay, good. Okay. Yeah, things like that you should really know how to answer. Raymond. Yeah. They're both infinite. Yes, but well, the contents are different, right? That's more important to note. Yeah. Questions?
The epsilon from 0, 1.
Oh, you mean the epsilon? Apparently, epsilon will be in this language here, not there, because this is the minimum you will get, right? Okay, this will be also talked about with more example in the later slides. Okay, so now you can try to convince yourself why this tells you the language with odd number of ones. Okay, think about it. And then basically just different notation from the diagram notation for DFA, NFA, and epsilon NFA. Okay, and writing regular expression is just like writing arithmetic, just like different operators. So what operators do we have? We'll see. Okay, and they're just equivalents notation. So now I want to talk about just the possible, a little bit formal. Okay, let me talk about this quickly. Okay, I'll go over that quickly, and then we'll talk about regular expression and then more example. Okay. Basically, you can think about if L is a regular language and M is a regular language, right? If you try to take a union, basically what? Just union of all the words. That was very easy, okay? And then if you got language L and language M, if you put L up followed by M, you're basically trying to do the following. You're generating a set of string of length 2. The first character from the first language, second character from the second language. For example, easy. Let's say L is just AB. M is simply, let's say, 1, 2, and 3. First of all, what's the cardinality of Ln? I heard 6. Agree? Will be 6. Okay. In case you are not too sure about it, basically just numerate them all. A1, A2, A3, B1, B2, and B3. Okay. All right, so you also got a cleaning closure over here. So that means L star, basically just all the length, and union them together, right? Basically basically L1 union L2 union L3 all the way together, and then you will get L star. Basically all the string of different length. Oh yeah, absolutely. Thank you. Good. All right. Now, yeah.
String length 2. When you say the length of string is 2, do we count the number of individual characters, or we count we measure corresponding?
Yeah, I know what you mean. So I would say if there's any ambiguity in the quiz or exam, I'll make it very clear. Yes. I would say in principle, you calculate the number of characters in principle. Right. All right, after this, let's do another one. Good. Okay, so now basically these are just regular languages, but now let's see the kind of operation we're doing over here, how we can use regular expression to do the language operation. That's why I'm doing this first. Okay, for regular expressions, so now the easiest one you can write is you can say just epsilon. This is a valid regular expression. Okay? What language does it correspond to on the right-hand side? When you say nothing, it's like an empty set, like an empty language. But really? Just an empty string, right? So it's a language of size 1. Agree? Okay. So that's why I'm just blacking them out just to see. So this one just a single language, a language with single string. So that means if you, think it this way, if you write a regular expression like a epsilon, that simply corresponds to this particular language over here. That's a base case. Okay, now you can also write empty set. So what will be the corresponding language? Empty language. Yeah, size 0, just empty. Okay, basically the right-hand side will just be a set of strings. Okay, so now this is just a single character over here. So what would that be? Just A. Okay, that's also easy. Just A. A. It's a single character, right? A. Yeah. Okay, so far we talk about base cases, but now we're saying, let's say this. If you have a regular expression E, you have another regular expression F. So E and F, they are regular expressions. And then you're applying the plus here is a regular expression operator, is one of them, operator. If you do that, what would be the corresponding language? Language E union language F, right? Don't say E union F. That's not exactly right. Okay, good. Okay, very good. What about this guy here? It's like a well, basically you'll be a set of languages of size what? Yeah, it will be a no, sorry. It will be a language where each member string in the language will be of size 2. You see what I mean? So you got E here followed by F. So that means you're going to get a language of size 2 strings. Okay? So that's why you will see something like this. Just concatenate them. Okay? And to go a little bit further, this is what you will see in the slides. It will just be a set of x, y, such that, so x, y concatenated together, x is in LE, and y is in LF. Okay. Okay, so this one here, okay, I'll just tell you. Okay. Basically, whatever, if you say cleaning star, so the point is the regular expression operators correspond very closely to the operator you can perform on the regular languages. That's the point. Okay. So it will be whatever language it is for E, and then you take cleaning star. So now, one thing to note, the cleaning star over here is the regular language operator. The cleaning star over here is the regular expression operator. Okay, and the equality just show how they are related to each other. Okay, final thing. Basically, given some regular expression, if I put parentheses, does it really create a new language? Not quite. Okay, it will be just like that. Okay, so now these are all the operators we should know. Okay, so that should numerate them all. Okay, again, if you want to really use E vertical bar F, that's okay. Okay, in the test. Okay, so now let's do a very quick exercise. Okay, some question for you, but that's something we already answered. Okay, that's easy. Okay, you can also look at that. Okay, we talk about base cases. I'm not skipping anything, so we already talk about it. And also we talk about recursive cases. Okay, that is also done. Okay, exercises. Okay, how about this? This one is kind of interesting. Just epsilon? Okay, why? I'll just only do this one with you guys. Okay. I'll copy that and then I'll switch. Think about what this is trying to say. Basically, you're saying that this is basically a regular expression, right? It's basically the corresponding language L of empty set. The corresponding language would just be this. Okay? So now I'm saying that I'm taking the cleaning star of that. What would be the corresponding language? Mm-hmm. Yeah, something like that. Basically, that one there, first of all, would be this of size 0, union this of size 1, and this of size 2, and etc. Okay, let me talk about just two of them. What would this be? Are you sure? Just empty string? Would it be just that? The set. Because remember, this is going to be a language, which is always going to be a set. And every string there, it should be of length 0. That's why it's only epsilon. Okay? However, this guy here, what would it be? Empty or non-empty?
Just the empty.
Yeah. We're thinking this way. This guy here is like a set notation. X, just a single character, such that X is a member of empty set. There's no such thing from the empty set. So the overall is going to be empty. Okay? And similar for this guy here, it will be X, Y. X should be a member of empty, and also Y should be a member of empty. And that one should be also empty. So overall, you will just get just this overall. This one is a little bit tricky, okay? Just to remind you.
The set of the empty set is not empty, yes?
The set of empty set, you mean over here? This versus empty set, they're different. Yeah, apparently you can see this is a set with a single element, which is empty set. And this is a set of nothing, right? Or thinking this way. This is a set where every element is more like a set. But this one, you have no idea because it's just empty set, right? All right. Good. Okay, you can look at others just to see. Okay, should we do just one example for regular expressions? Just one. All right. Why don't you think about it? Think about it. I would suggest the following to be more efficient. Think you can definitely jot down something on your paper to see how it would look like, and I will show you something on the slides to see that correspond. If you want to suggest something to us to discuss, feel free. Okay. Think about it. You don't have to write it down. Just think in your mind. That's fine. I'll just give you 1 minute or 2 minutes. And as I said, when we grade your quizzes or exam, of course, there's no restriction on what you can write as long as you're using valid regular expression operator. So the way I grade it would be, I will look at that and try to see if I can find any counter example. For example, something that's accepted by your regular expression, but it's not accepted by this set. If I can find it, that means you're not perfect. Okay, something like that. Okay, just maybe a little bit more, longer. Okay, let's build a little bit gradually over here. Basically, we got alternating zeros and ones. Can I say 0, 1, star? Would that cover part of them? Yes. But not all of them, right? Okay, so for example, what about I say or 1, 0, star? Do you think we're good? We're getting there. Okay, yeah.
It should be 0, 1, or 1, 0.
Yeah, somehow we just miss, well, for example, what if, let's say, do they actually cover something like 1, 0, 1? This is alternating, right? So that means before this guy over here, it might be 1, or it could be epsilon. Do you see what I mean? So basically, this is like a or, right? So that means I can either take this one here and then say 1, 0, 1. So that's definitely there. Yeah, question.
Put 1 star instead of 1 plus epsilon.
If you say 1 star,
Yeah.
that's not good. You're basically, okay, what you're suggesting is this. If you say 1 star and then 0, 1 star. Guys, would that be okay? Okay, let's say you give me this on the quiz, right? What I will do is, I will tell you that this is not good because, for example, this accepts apparently 1, 1, 0, 1.
Okay.
But this is not in the language. Okay, that's kind of the thing you want to think about. Every time you come up with any regular expression, try to challenge yourself, basically. Yeah.
I don't like. Oh, you did.
Oh, I haven't finished that yet. Oh, yes, or. Yeah, again, yeah, exactly, that's or. Sorry, that's a plus. Okay, similarly, before the 1, 0, it can also be 0 plus epsilon. Guys, it's just one way to do it. Mm-hmm. Do you have anything to suggest if you want to discuss? Hmm? Wait, oh yeah, exactly. Yeah, you can see the 1. Okay, overall it's going to be like this. 1 plus epsilon followed by 0, 1 star plus 0 or epsilon 1, 0 star overall. Okay, so that's just one example. Okay, so I think the best way for you to practice would be, okay, I'll get to your question. You will see there'll be many examples I give, maybe for DFA, for NFA, or for other things. You can try the regular expression on them. You might be able to find some exercises in the textbook as well. That'd be the best way to practice. Question?
Shouldn't there, at the end of it, shouldn't there be a 1 plus epsilon again?
I think so, yeah. So give me if you are thinking about maybe 1, 0, 1, right? But 1, 0, 1 is covered here. Yeah, it's covered, yeah. Shouldn't it be the whole thing?
Yeah.
So what do you mean?
Like the entire.
You mean parentheses?
And then star.
Yeah, actually, interesting. What you were saying is, okay, temporarily, can we actually do this and then do the star, right? Maybe not, because somehow the way you combine it together, maybe you will break the alternating rule, okay? Okay, so maybe not, okay?
How would that star go with the or?
How would the star
Go with the or?
go? Oh,
The star on the outside of the blue, the last one that we just added.
oh, you mean what if you put it there, right?
Yeah, we put it there.
Oh, okay, I see what you mean.
We can do the second one. Or
Okay, basically, yeah, exactly. So now if you put it there, it's as if it's like this. Think about this guy here is like an E. Think about this guy here is like an F. So you basically got E plus F and then star. Okay, so now basically you're saying this. You can actually basically either think about zero or more repetitions, right? If I only got 0 repetition, it would just be empty. Okay, or it can be maybe a single character such that it is from E. Or it can be Y that's from F, right? And then, or it can be 2, and then in that case, so X and Y. So now, basically, X will be from E union F. Well, it should be language of E, actually. I'm just being a little bit imprecise over here. And Y, E union F.
Okay.
Actually, different repetitions. Yeah. So Raymond, do you want a more concrete example for this?
Okay.
You're okay, right? Okay. How about, I just want to do it. Okay. How about that? You want to renumerate a little bit? Just the first few. A and B, let's say. A is a character, B is a character. Let's say they are in the alphabets. Apparently, that's going to be, first of all, empty string, right? 0 repetition. Or it can be A, can be B. And now, when you choose, let's say, 2 repetition, right? In that case, you can be AA. The first and second time, simply choose A. Or it can be BB, can be AB, and it can be BA, and then etc. Okay. No problem. Okay. Okay, actually basically just talk about exactly what I just said. Okay. Okay, so now these are some exercises for you. Okay, so over here. I'll try them and then you can show them to me later. Just different examples. Yeah. You don't really get solutions, but I would say as soon as you're done, either send it to me by email or just come to me with your solution. I'll look at that. Yeah. Either you let me check your solution during office hour, or I can check your solution in the test. Either way. You can choose either way. Yeah. But give it a try. If your time is really limited, at least trying something, right? Yeah. Okay, operator precedence, basically we talk about it. That's the only thing you have to memorize a little bit, but it's quite straightforward. Cleaning star got the highest precedence, and then followed by concatenation, and followed by union, okay? So let's say, example here. Oh, that's something we talk about. Okay, question here, just do another one. Think about if these two are equivalents. Yeah, the second one. Are they equivalents? Okay, let me copy that down and then we talk about this. 0, 1 star versus, okay, as usual, if you don't think they are the same, you want to give me counter example. Huh? Just one? Okay, you're saying one exists. Oh, good. Apparently, if one, that means you simply choose this part here, right? Because it's a plus. And then one does not exist. You got to start with 0. Okay? Apparently, one exists over here, but not here. Okay, sorry. Is there any string you can give to me that's in here, but not in here, in the left-hand side? Yeah. Think about L2, L1. Is there any string that's in L2 but that's not in L1? It's a subset, exactly. Yeah. Oh yeah. That's true. That's true. Yeah, of course. Of course. Now we don't talk about simplification, right? We're just saying what you're given. Yeah, absolutely. Okay, so I'm just saying they are not equivalents. Okay. Anyway, you can do a little bit more reasoning yourself. Uh-huh. So I would say this. Basically, in the test, I might just give you these two regular expressions, and then I would just say justify if, let me be precise to you. Let's say expression 1, expression 2. If E1, L of E1 is the same of L of E2. In that case, you don't have to say one is a subset of another unless I ask you to do it. So now, in order to show that they are not equal to each other, you just want to show me one string that exists in one but not another. That'll be enough. Okay, that's all I expect. Okay. All right. Okay, there's another example. You can take a look. Okay, that's about regular expressions. Any questions? Basically, so far we just review about alphabets, string and language, and also a problem, and also about regular expression. Let's now get on to DFA. Okay, good. Let's see if we can at least finish DFA and NFA. Okay. Okay, DFA, deterministic finite automata. Don't worry, I'm not gonna ask you to spell it in the quiz. Okay, but at least know it. Okay. But can you actually spell it? You can, right? You know, you can. Oh, really? Okay, don't. Oh. Yeah, that's fine. That's fine. I'll excuse you for that. All right. Okay. Anyway, finite state machine. Okay, we got. Okay, I think that for the normal knowledge over here, I'll let you read it. Okay, it's we don't have to waste your time. Let me see anything that's important for us to see. So a typical problem could be, I just give you this particular language description. So this is a set. I want you to really specify the DFA that will recognize it. Well, this one should be extremely easy, right? That's like a Hello World example for 2001. Oh, yes, two-state, exactly. Yeah, that one's easy. Okay, I'm not going to trouble you with that. We'll do something a little bit more complicated. Sure. Okay, that's a very good question. I would say if you really have enough time, if you're doing that very fast, if you really have no clue about how to come up with a regular expression, one way to do it is to come up with maybe DFA or epsilon NFA, and then there's a way to convert that into regular expression. But depending on how familiar you are with the process. No, actually, the way to really yeah. So the way to really convert the state machine into regular expression is something called state elimination. That one is actually quite complicated, so we may not cover that here. Yeah, to alleviate some burden. Okay, we don't need it. How about that for this course? Okay, so now how about this one? Let's say we have this language here, 0 and 1s, and then it's going to be all the string W. First of all, W is not empty. And then they have equal number of alternating 0s and 1s. Okay, let's say. You can do other things as well. Okay. For these two, I'll leave them as exercise for you. This one, these two. Okay. How about we just do this one here? Okay, I'll switch to the iPad for you. This guy here. Okay, how about this guy here? Oh, okay, what I meant was this. So for example, if you got 0, 1, 0, 1, so it turns out the number of zeros you got is 2. The number of 1 is also 2. On the other hand, if you got 0, 1, 0, 1, and 0, in that case, you don't have equal numbers of zeros and ones. Okay, so this is okay, this is not. And of course, during the quiz or exam, if somehow the language description is not clear to you, just ask. Okay. Huh? Sorry? Yeah, exactly. For regular expression, or I would say let's now focus on the DFA first. For regular expression, you can also try. Okay, think about roughly how you might do it. Okay. Huh? It's actually the same exercise as before. I can tell you that for this particular one, it might be more convenient to specify using DFA. But using regular expression could be a little bit more, require a little bit more thinking. Yeah. Mahu? Yes.
Like, you can look at it like, at the start state, you have to go, like, you need like to say beginning, you know, I don't know, in total, but for the start state, if you see a 1, you go to the states here, which is, then you have to look for 0, and you start with 0.
Yeah, you gotta watch out for the zeros and ones for sure. Okay? Okay, how about I show you the solution directly? Okay? I would suggest this. We're gonna discuss briefly about one possible solution for this problem here, and then when you do your exercise, try to cover the solution and do it again to see if you got something different. If you got something different, try to challenge yourself if that will work. If you're not sure, talk to me. Okay. Go ahead.
What's the notation we're using for the DFA here? Are we using circles and
Oh, yeah, exactly. Oh, we'll see. So let's see the example. Yeah, so you will see. Okay, so the example, okay. Let me just get a solution here. Okay, not here, sorry. Oh, so here's the notation. Yeah, I think the same, right? You just have to put double circle for accepting states. And then starting state will be just with the incoming edge only. And then you may have self loop and also states, right? I would say for what's inside the circle, depending on how I ask you to do. If I didn't ask you to describe a state, you can just give 0, 1, or don't even put anything. That's okay. Okay. Sometimes I might say, apart from the circles, you have to explain what each state really means. Okay. For example, in the easiest example here, if I start with over here reading nothing, so that means so far the number of zeros I've read is even, right? And then otherwise it will be odd. Okay. And I put a double circle for accepting states. Okay, just some terminology to review for yourself. Okay, and now let's have a look at the solution. Okay, let's go over that. Why don't you have a quick look, just for 1 minute? I'm going to prepare that on the iPad, and then we'll go over just some details of that quickly. But somehow I put the description inside the circle, so hopefully it's kind of obvious. Okay, so now let me just go to iPad over here. Basically, you can see we start with this particular states, which means so far we have read just empty string so far. Okay, so now we're going to branch out. Either the first character start with 0, or the first character start with 1. So two possible states. So the two branches should look very symmetrical. Okay, let's say we go with 0. If we start with 0, the next character should be 1, right? In that case, if you actually go to 1 over here, this is very good. So now 0 and 1. So now, so far, you got equal numbers of alternating zeros and ones, okay? So that means it should be accepting states. However, you might repeat this pattern by 0, 1, and then you can also say 0, 1 again. So that means if you go 0 here and go 1 here, you go back to the original accepting states. Okay, that one's easy. So now, let's say so far I have read just initial 0. And then somehow I'm just breaking the pattern at some points. So I might just go 0 here. So now I got consecutive rather than alternating, right? So this will be the so-called dead states. Once you reach these states, any zeros and ones is not going to lead you out anymore. So just dead states. Yeah, it's dead states, not the accepting states. And notice that this is called DFA because you can see for every states we have over here, we got exactly 2 transitions going out, right? And they simply just correspond to the number of transitions is simply equal to the alphabets of our string, which is just binary, zeros and ones, okay? So exactly 2 going out and also 2 going out, etc. Okay? Try to see if you can understand this, and if you can, try to see if you can redo it. Feel free to be different from this, but make sure it's correct. Questions?
Why is it not also final? Because string is always finite, isn't it?
Oh, you mean it's not empty string?
Well, no, state 5, isn't it? The string is always finite.
Oh no, S5 simply means you already have broken the pattern for the alternating. Take a look to see how you can get to S5. For example, I'll get to you. So one way to get to it would be if I got 0 over here and then I got 0. So we got 0, 0. That's already broke. Okay? Or it might go 0, 1, 0, and then 0. That also is breaking the alternating sequence. Let me
We finish in any state but state 5 is correct?
Nope. Yeah, let's go a little bit further. Okay, that's a good question. Let's just see informally how we can decide that, and later on we're going to see how we can do it formally. So now let's say, for example, apparently you can see your terminating state should be either S3 or S4. Equal numbers, yeah. So for example, if we got 0, 1, 0 and then 1 over here, and that's it. So now the terminating state is accepting state. That's fine. Okay, 0, 1, 1, for example. In that case, 0, 1, and then 1. So now terminating state is simply not one of the S3 or S4. So it's not going to be accepted. Right? That's informally speaking. Okay. Good. Yes. S0, oh, it should not be because remember, one of the condition is should not be empty. Don't forget. Yeah. But I would say, of course, if you somehow accidentally circle S0 as accepting state, you would definitely get partial marks. Not a problem. Yeah. Oh, yeah. If that's what you're concerned about, right? Yeah. Yeah. Okay, so now let's go a little bit further. Question?
In the textbook, if we don't have 1's coming from S3 and 0 coming from S4, so if the input symbol is not defined for the states, if they go to error state.
Sorry, I don't quite. Yeah, can you say it again? I don't quite follow you. Can you say it again?
Textbook defines the reject state as everything that's not defined close to reject state. Like, for example,
Yeah, so accept say you meant.
no, reject state.
Oh, I see. So here, yeah, it's a little bit different. Yeah, you can definitely try to follow the textbook. That's fine. But I would say the way I do it over here is simply say if, let's say, if you got 0, 1, A, for example, if that's your input string. Thank you. Let's say if you got an input string 0, 1, A, right? I'm going for 0 and then I'm going for 1. But now in this say over here, there's no a, so undefined, so it will be rejected. But you can assume we are not going to give you some string consisting of invalid character. Okay, so for your DFA, you always only consider valid character from the alphabets. That's something you can assume. All right, good. Just make things easier. So you don't really need to get explicit reject states. Okay, so these are some easy problems for you to review. Okay, in the quiz, I'm not going to give you something that's too difficult. Don't worry. You know. Yeah, just at least you can do some basic stuff. And yeah. Okay, so now about DFA, how do we formulate it, right? So now this might look familiar to you. Okay, let's do that quickly. Okay, maybe just for the DFA we can do a little bit more thoroughly, but once we get NFA and epsilon NFA, they'll be very similar. So in that case, we can be faster. Okay, just for the first one. Okay, just want to get a formal definition. Basically, the way to basically given any DFA like this, okay, you can think about this. The advantage about knowing the formulation is you can somehow have a domain-specific language for DFA, if you see what I mean. And then the way to design what the components should be in a DFA language, look at the Q, look at sigma, look at delta. Those should be there. Okay, I'll give you a little bit more insight later. Okay, so Q, all the states, and sigma will be the alphabets, and delta will be the transition function. Q0 initial states, I might be using a little bit slightly different alphabet, like a character from the textbook. So far the same? Oh, good. You know what? Because the slides here are based on the 2001 textbook. Yeah, that's why, which might be good. Okay. Anytime you find any kind of difference in the textbook or the slides, you can use either. Okay, but if you got confusion, just let me know. Okay, and F will just be a set of states that'll be accepting states. A very easy question would be, so now for Q, it will just be basically S0, S1, S2, S3, S4, S5, right? Easy. Maybe I'll just give you a diagram and ask you to do the formulation. Okay, yeah. Okay, okay, other things are very easy. So now what about F? S3 and S4, very good. Okay, so now the only thing you have to know is also quite easy, is how to specify delta. Exactly. Okay, so if you look at the slides over here, I'll just mention that quickly. So delta over here is saying delta is going to take two inputs. It's going to take a single states, the current states, and then followed by some input character I'm going to read. And then it will transit me into another output states or another next states. Do you notice that this is a total function? There's no, well, you know the difference between total versus partial function, right? Total function versus partial function. Okay, what's the difference? For example, is division a total or partial function? What's the definition of total function? Good. Okay, let's clarify that. Okay, a total function simply means the result is defined for every domain value. For example, think about division as a function. From integer to given to integer, it's going to give you another integer. So it would not be correct. It wouldn't be correct if I say division is a total function. 0 is not defined, exactly. So it should be a partial function because division of, for example, 3 divided by 0, undefined. That's why it should be a partial function. Okay? And total function means any domain value will be okay. Okay? Yeah. So now you can see the transition function here is simply total, which means we assume you always give a valid state, you also give a valid character. Okay, you don't have to worry about when you only got binary string, you actually got an A. You don't have to worry about that. Okay, make things simpler. Okay, transition function. The only thing you have to know about transition function is how to, let me just show you quickly how to draw it. Are you okay with the transition function here? Basically, let me just do that quickly for you, just for one, quickly. Okay, I'll give you the idea. And then I'll go to the language. Okay. So now, how do you draw the delta for that? Delta is going to be a table, basically. Okay, and then usually you will enumerate all the states as the current states. Think about this as current states. Okay, this will be the input character. Okay, so now current state could be S0, S1, can be S2, can be S3, can be S4, can be S5. And then you have, let's say, what can be the possible input character? Zeros and ones. Good, thank you. Okay, let's just do one row. Okay. We don't have to do everything. If I'm currently in S0, okay, and then we go to S1, right? And then if I got 1, I go to S2. One thing to note, for the case of DFA, the resulting state is a single states. For NFA, it's a set of states. Okay, but we're going to do that today. Okay, I'll get to the formulation maybe first thing on Wednesday. But let's go to NFA first. Okay, are you okay to finish the table? Should be okay, right? I don't need to insult you by doing it. Okay, good. But if you insist, I can do it. No, let's not do it. Okay. Okay, the formulation here is about how to see the accepting language. I'll do this together with NFA on Wednesday. Okay, I'm not skipping it. But let's do NFA quickly. Okay, this is the solution, just in case you want to check. Okay, so now these are some examples you should do for DFA. Okay, let's do NFA quickly. Here's my question for you. Let's say this. Given this language here, which will be basically a string of size, it's going to be a string of size at least 2, right? And then somehow we can break the string into 2 parts. The second part is simply 0, 1, ending with 0, 1. The first part is x, which can be any arbitrary string drawn from the alphabet 0, 1. So now the question is, DFA, how do you do it? Well, it's doable, but it might require quite a bit of consideration. So this kind of problem here is somehow it would be very nice to have some non-determinism over here for the specification. Okay, NFA is actually, this is kind of the problem you can actually specify using NFA. Okay, let's see. Let me just go to, okay. Okay, so now let's say this language here, we talk about it, right? X and 0, 1. I might have that in D. Oh, actually, I do have that. Convince yourself this is a DFA, number 1, because for every state, you got exactly 2 transitions. And number 2, convince yourself the accepting language here is really the same as L. Okay, 2 things to confirm. Now, this is absolutely good, but it would be more convenient to actually allow some flexibility when you specify it. Okay, so now let's see this. So now for NFA, it's like this. It's a thinking logic here. Let's say I'm starting with this particular states. Okay, somehow I'm allowing myself to be a little bit ambiguous, a little bit. This particular state can be, remember it's a pattern, x and 0, 1. Okay, it could be that when I'm actually in this particular state, I might be already at this part here. So that means after that, I can simply do 0, and then I can do 1. And then I can simply accept. Or I might be somewhere in the middle for this particular x, in which case I will add, okay, I may be somewhere here, so I'll just do 0, 1. So this is also a valid solution for NFA. And why is that not a DFA? Yeah, exactly. You can see apparently you allow some non-determinism. When you take the input 0, you don't really know where to go. You might either go here or you might either go here. You don't really know. However, whichever way you go, as long as you keep track of them, and then if any path eventually to a valid solution, then you're fine. Okay, we're going to see. Okay, that's an NFA example. Okay, so what I would like to do is to show you quickly how you can read string for the NFA. Okay, let me just do that, and then for the last 5 minutes. Any one of you actually took physics before? High school? University? No? How far? Well, basically, okay. I once read a passage in the textbook, maybe in the same textbook you guys have. Anyway, they actually mentioned that in the 2001 textbook. Maybe they're referring to some physics. They talk about something called parallel universe. Okay, parallel universe basically means, so there's some parallel universe that we all exist in that particular parallel universe. Might be doing something different, right? Maybe in other parallel universe, you guys are not students, right? You might be. Yeah, branch out basically, just different possibilities, right? Okay. Huh?
It's like, yeah, we branch out, but eventually one, hopefully one.
Yeah, exactly. Well, yeah, that's I'm just trying to make an analogy. That's my point, right? So parallel universe. Okay. So now what I want to do is to go over one example for you. Let me just do something even easier. Let's say if I got a string 0, 0, 1. First of all, do you think 0, 0, 1 is a member of the language? It ends with 0, 1, right? But now we want to see exactly how the NFA is going to accept it. That's what we want to see, okay? So now let's see that. Let me do a little bit more informally. The initial state is simply just Q0. Okay? So now, when I read the first character, so I'm going to read 0. How many possible states I might go to? 2, right? Yeah, it can either be Q1 or it could be Q0. So now these are two parallel universes, right? Or just two branches. Okay, 0. And then, so now, when I'm trying to read the second character 0, I got to consider for both branches, right? So now for Q1, I might take 0. Can I take 0? No, we're stuck. So Q1 over here, we are stuck. Because for Q1, there's no 0 over here, right? But now what about for Q0? Are we okay? Yes. Yeah, for Q0, we can definitely take 0. In that case, how many possible states? Again, 2, right? So now we can either take 0 over here, and then we go to Q1. Or we might go over here, 0, back to Q0. Okay, finally, 1. Okay. Yeah, exactly. So basically, you just want to try 1 for both branches, right? So now for Q1, if you are now in Q1, if you try 1 over here, you're going to reach Q2, okay? And then so I'm running out of space. But now for Q0 over here, if you take 1, you're still going back to Q0. So now you got 2 possible terminating states. So as long as one of the possible terminating states is an accepting state, then the string should be accepted, right? Okay, now you can see this is basically Q2 over here is the terminating states and accepting. Okay, Any question about this? Okay, this just informal. We're going to continue with this maybe on Wednesday. Are you okay with the pace? Too fast, too slow? Good, okay, good. Okay, we'll continue with this on Wednesday. On Wednesday, go to Very Hall. I'll confirm with you on Moodle, okay?